Yeah, hello everyone. I hope I am audible. Yeah, so there is some electricity problem today going on in our observatory. So if suppose something happens, I will again rejoin. Yeah, so maybe it can go sometime. So okay, I'm sharing my screen. I hope the screen is visible, right? Okay, let me start. Yeah, good evening everyone. I would just like to switch off my video. Yeah, welcome everyone. So this is as you all know, this is a workshop or summer camp going on based on citizen science and what is the importance of citizen science in astronomy. So I wished that I would like to focus on a particular area related to citizen science, that how citizen science or what is basically citizen science, what citizen scientists do. These are some topics which are, I believe that it will be amply described by some other speakers also. I have seen the list of speakers. There are so many good, well-known citizen science speakers in this camp. So instead of going into very details about how citizen science started and what we get from this, I would like to basically concentrate on, in my topic is key, in the field of professional astronomy, how citizen science helps, especially in our area, in the area of astronomy research, how it helps. So this is why I would like to give a brief introduction. Yes, nowadays we know these are all known pictures to you all. Just to give a very brief idea, we know that we people who are belonging from big cities, big towns, we are facing a problem at night, that is the light pollution. So you see, if we go to some places like these, America, India, Europe, these are the places where light pollution is very heavy. Instead, if you can go to some places like, you see, this is Amazon jungle or Sahara Desert or the northernmost parts of our world or some places where there is oceans, we see the light pollution is very, very less. So as this light pollution problem gradually increased due to the development of science and technology, development of humanity, population increased, we now want to actually take the help of astronomy researchers who do not belong to professional astronomy also, because it is not always true, it is not always possible that astronomers or professional astronomers will be coming to remote areas, they will do their work, and what others will do. Is it possible that in astronomy field contribution can come also from the field of non-professional people? Yes, it is possible. So if we go to these places, like these areas, some remote places of the world, at night we see a very wonderful sky like this. But if we remain in some big cities like Bangalore, Calcutta, or any big city, big towns, we see the night sky like this, where we barely see some stars. So we know that looking into these wonderful skies, this is a sky which we can see if we go to a place which is very away from city lights, which is a very remote place. This we can get in some remote jungles or remote desert areas or from oceans. In these kind of places only we can make our astronomical observatories, where very huge telescopes will be there, ground-based huge telescope facilities, sophisticated instrumentation, through which we can observe the sky, we can study the objects which are present in the sky. Maybe it is planets, it can be galaxies, stars, it can be comets, whatever it is. So presently, as I am situated in this particular observatory, I am talking to you people sitting in this observatory. This is known as the Vainobapu Observatory, which is operated by Indian Institute of Astrophysics, headquartered in Bangalore. Now, this is an observatory which is, you can see the location of this observatory. Yes, it is placed or it is situated in a very remote position at the top of some hills covered by dense forests. It is a place in Tamil Nadu which is known as Kavalur. So this place has so many telescopes. Presently, I am sitting somewhere here in my hostel room, and I'm talking to you people. So these kind of ground-based observatories are utterly important for understanding the sky. because here at night you see there is no people around. It's full of jungle. There are no people, so no light, almost no light. And as a result, we get a very wonderful sky at night. So we can study the objects in the space. And yes, you see there is a dome here. There are so many domes here. One of the dome is here. So inside this dome, there is a telescope. There are so many telescopes. This place is known as the telescope town of India. So these are some of the professional telescopes which are used for observations and study of astronomical objects. Am I audible? Yes, there is some electricity problem going on in this place for the last 2 days actually. So it is just switching on. That issue. Much I have joined from yeah. Okay, these are the places. These are how actually the professionals look like. See,
Voice is not audible.
Hello.
Okay, I hope presently I am visible. Yeah. So there is some huge problem of electricity going on. So okay, please remind me if something like this again happens. Please give me a call or something. Okay. Okay. So as I was telling that astronomy is a field. Basically, astronomy is maybe the only field till now where non-professional people, where amateur people, where people who are not professional astronomers can also help, can also contribute. And these are some of the examples of famous scientists or astronomers whom we salute, who were actually non-professional people. Galileo, Copernicus, I am sure that at least these two names everybody has heard. Anybody who does some work in astronomy field for a few months, they will definitely hear the other names also gradually. So these people were basically not professional astronomers, but they have given ample amount of contribution in astronomy. And now it is the time, with the help of this sophisticated technology, internet, and all these things within our own hand. Now is the time when everybody from the world can actually contribute in astronomy field if you have interest. How to do that? Now let us give a brief idea. Okay, what is citizen science? Citizen science is a project, worldwide project, which is devoted to the objective that any public having interest in astronomy or interest in science can become involved in contributing in scientific research. So basically, presently, citizen science is a very huge project. There are more than 1,000 projects related to different fields of science, not only in astronomy. And in these different fields, you see there are more than 10 lakh volunteers across the world. So many official members are there who are doing or who are helping or contributing in citizen science projects. Now, apart from in this citizen science forum, in this citizen science, among these projects, definitely astronomy plays an important role. There are so many projects which are related to astronomy related research. What are they? Well, before going to that, I would like to give a very brief idea that you see when you look at the stars, you see stars also change their brightness. Stars also vary in brightness. Every time it is not possible to see a star varying brightness with naked eye, but with telescopes, if you go on observing a particular star, you might be able to see that the brightness of a star changes. For example, this is the picture of a pole star. Our own pole star also varies. You see, at particularly one time, pole star might become bit brighter, and sometime it might become less brighter. So these type of stars, which vary in brightness, are known as variable stars. Basically, most probably, every star in the universe are variable stars. There are so many types of variable stars, which I am not going to details. Due to so many reasons, variation occurs in case of stars. And studying these variable stars became one of the first prominent network or first prominent work where amateur people started contributing the most. And as far as if you go to the 19th century, so this is how observation of variable stars are taken. Nowadays also camps are organized where variable star observation is done. And why this study of variable stars is important in astronomy research, my friends, you will be amazed to know that by studying a particular type of variable stars which are known as Cepheid variables, our age of the universe was calculated. Universe is expanding. That expansion of the universe was discovered by studying Cepheid variables. Even the universe is expanding with an accelerating speed, with an accelerating rate. That was discovered by studying another type of variable objects or stars, which are known as supernova. There are also some kind of variable stars, these Mila variable stars. By studying these, we understand how our own sun will evolve. The future evolution of our own sun, we can understand by studying this type of variable stars. So variable star research provides a wonderful understanding about stars and their evolution. And if we go back in time, during the time of even 1911, this particular organization was created in America, American Association for Variable Star Observers. This is the largest organization in the world which provides you a database of all possible variable stars. Anybody who is interested, who wants to observe a variable star and wants to submit your data in this particular organization, you can do that. You can definitely do that. You need not have to give any money. There is no admission form, nothing is there. Only thing what you need is little bit of interest and maybe the help of some particular guidance from some people who will give you a basic idea about this, how to observe the variable star and all these things. Even nowadays, you don't need a telescope to observe and to submit data. And yes, the best person in the history, one of the best person in the history who has done the most amount of variable star observation in historical records was a Bengali amateur astronomer. His name is Radha Govinda Chandra. You can just type his name in Google and you can see what he has done. He was the person who submitted 37,215 observations to Howard College Observatory, to AFSO, and he's a world recognized amateur astronomer. Unfortunately, he is not that much recognized in our own country. He was being his observations. If anyone visits AFSO office, you will see all his observations completely sophisticatedly kept in a particular separate room. A complete room has been dedicated from AFSO to only one person, to only one observer, and that person belongs from our India. And yes, in our Kavalur Observatory, we have one particular telescope, which is a 6.2-inch refracting telescope, which was a telescope which was presented to Radha Govinda Chandra by AFSO in 1926. He has done more than 25,000 observations using the same telescope. Until now, we at Kavalur Observatory use this telescope for public outreach purpose. Every Saturday, anyone who comes in our observatory to visit the observatory, if the sky is clear, the telescope is used to show them the night sky beauties. One can go to this Google and type this person's name. He's a great contributor in variable star observation. So that variable star observation was one of the first works where people who are non-professionals started serving. And from that time onwards, presently, we have a complete platform. This is known as universe.org. And in this huge platform, if you just type it in Google, you will come to this page and you can go right to the space section and you will see there are so many projects. At present, more than 20 astronomy related projects are available. So this Zooniverse platform is the largest platform for giving you the details about all citizen science related projects which are carried out nowadays, which are active now. And one can just join any of this project and you can start contributing. Just to give an example, well, this kind of project, these volunteers, these non-professional people, right from the age of maybe 6 to 80 or 90, who are contributing in astronomy field for so many years nowadays. This astronomy citizen science started from 1990s, and now we have lots of projects where citizen scientists can take part. So you see, you go to this place where NASA is having an archive, where NASA has given complete, they have quoted the names of all those citizen scientists who have given such good contribution that any research paper which is published, these citizen scientists who are non-professional people, they are also co-authors of those refereed proper scientific research papers. And you see, there are more than 400 people across the world who are not professional astronomers, whose names are featured in some research paper. This is present in this particular NASA archive website. So basically in India, yes, in India also we have some particular citizen science oriented projects. This RAD at home, radio astronomy at home, sitting at home. RAD at home is the first citizen science project of India, which was developed by Dr. Anand Dhota in 2013. It will be 2013. So this is a project where anyone who is interested and who is pursuing a BSc or BE, means you have to be a graduation student. This is not for everybody. This is for graduation students doing science graduation. You can join this group and you can contribute in radio astronomy, in understanding the images taken through radio telescopes. Mainly the images are taken by Indian radio observatories. So apart from that, our Indian Institute of Astrophysics also has an initiative, which is a collaborative initiative with, this is known as Pune Knowledge Cluster, a big organization from Pune. Here, we have developed a particular project known as 1 million galaxies. This is another citizen science project where anybody can go to this particular website, join this project free of cost, no age limit, nothing is required. You just need some little bit of interest in astronomy and some little bit of time, maybe once in 1 or 2 hours a week. So if you have that time, if you have interest, you can join this project, and everything is automated. You can sign up, make a login account, and you can start classifying the features present in a galaxy. The images of these galaxies will be given to you, which is coming from the Subaru telescope from Chile. It is an 8.2 meter diameter professional telescope. We get ample amount of images from this telescope. And what people like you what people who are non-professionals can help us is, you can join this project. We do not. The people who are doing professional astronomy is very less in the world. We have ample amount of galaxy images coming every month. And what are the particular features present in a galaxy? We do not have time to classify that. So that is why we are taking the help from Indian Institute of Astrophysics in collaboration with PKC. We are taking the help of citizens of all over the world. This particular project will definitely be described by another speaker, Mr. Atharva Pathak, who is part of this PKC and this project. In some other day, I definitely sure he will be giving you the explanation how to join this project. So I'm not going to the details of this. Just to give a brief idea, yes, there are projects from India also where you can join free of cost. And if you need some guidance, well, if I want to join a project, how will I join, what to do, what not to do, how will I start? If you are confused about that thing, well, this citizen science in India is progressing. And presently we have this group, a WhatsApp group, which is probably the largest citizen science group in WhatsApp, mainly made by Indians. And presently this citizen science group is known as SA Citizen Science Group. Anybody can join this group. You can mail, or you can just go to this group member, Mr. Shovanacharya, who is one of the founder of this group. You can just WhatsApp him and join this group. So this group presently has, I guess, more than 300 members all over the India, in almost every state of India. We have volunteers, and more than 20 projects are being run by this group. And you will get, if you want to know that, okay, if I want to join this galaxy classification project, how to join, what I will do, how to do. There are teams in this group who are very, very well aware about these things. They are doing these works, and they will be happy to help you. Only thing is that you have to show the interest and join the group and start conversing with them. Nothing, no fear, nothing to do. And for example, anyone among these who have joined today, if you have joined the first session yesterday, you have heard the talk from this particular small boy, who is also like many of you. He is a schoolboy, Shourjya, who is also a part of this group. And he has also done so many good works related to searching of asteroids. So as a result, he has received recognition. He has received certificates from different parts of our world. Apart from this, what is this? Well, asteroid searching is very important. Now, there is a particular project which is known as this IASC, International Astronomical Search Collaboration. Under this project, This is also a huge astronomical collaborative project for citizen scientists. Anybody can go to this website, you can join definitely, and you can start taking participation in searching of new asteroids. In Indian soil, the first two persons who were non-professionals who actually discovered an asteroid were these two boys, class 11 students. They were non-professionals in 2011 from Delhi. If you can go to this particular website link and check what they did. And apart from these two boys, nowadays we see the youngest citizen scientist from NASA, the youngest NASA citizen scientist is from our own India. He is a 9-year-old boy from Calcutta who is also a part of this asteroid search campaign, who has helped till now in finding out 5 asteroids. This is written in Bengali because all these things came in Bengali language, in Bengali newspapers. So this was Arush Nashkar, who is presently also a 10 or 11-year-old boy, and he is doing really good work in searching of asteroids. This is just to motivate you people. There are so many ample amount of works going on under the help of so many citizen science groups, even SS Citizen Science Group, and you can take part on that. Now, maybe I will take another 2-3 minutes time just to show that what in our area of work do we take the help of citizen science in astronomy research, hardcore research, how we take the help of citizen science. Well, I specifically work in a particular area which is known as stellar spectroscopy. I study the spectra from stars, a particular type of stars, and these stars are very peculiar stars. So basically, not going to any physics, just to give a very brief idea, if you take the spectra of stars, you will see absorption lines, which tells us what are the components, what are the elements present in the outer layers of the star. But there are some stars, when we take the spectra, we see emission lines opposite. And these type of stars were first discovered in 1866 by this person, Father Angelo Secchi. This was the star Gamma Cassiopeiae in the constellation of Cassiopeia, the middle star. This was a stunning discovery because people never expected that the star, if you take the spectra of a star, that spectra will show you emission lines. And these type of stars are known as emission line stars. What happens is these stars are surrounded by some gaseous or dusty disks. And these disks are the places from where the emission lines come out. So if we can study those emission lines of different elements like hydrogen, like helium, calcium, then we can ultimately understand the physics of the disks of stars and how the disks of stars are connected to the stars. So we or my team, we study a particular type of emission line stars. Basically, they are known as classical BE stars. They are very massive stars. They are also young stars. Their mass is around 3 to 20 times that of Sun. Radius is around 3 to 15 times that of Sun. They are the most rapidly rotating non-degenerate stars in the universe. And they are covered by, or they are surrounded by, same way, a gaseous disk. These gaseous disks are the places from where the emission lines of different elements come. So we see emission lines of iron, oxygen, hydrogen, calcium, so many. So if you see the spectra of such a star, a BE star, this is how the real spectra of a BE star looks like. You see these are hydrogen lines, very prominent. Well, no need to remember what is H alpha, H beta. But basically these are hydrogen lines, these are iron lines, these are oxygen lines, all emission lines you see. These are if we study them, this tells us how the BE star disks behave, the properties of BE star disks and everything. But amazingly, we have seen that in case of these particular classical BE stars, the whole disk itself can vanish anytime without any notice, without any phenomena. Means the disk can suddenly vanish, it can again reappear without any warning. And there comes the importance why we study. So these stars are also very highly variable stars. And as the disks of these stars can vanish anytime, So we can ultimately study the variability of these disks by continuously, on a regular basis, by continuously monitoring any particular B star for long time. How will we understand the disk is not there? Suppose if we take the spectra of a particular B star and we see that all lines are in absorption, all are in absorption lines. We are not finding any emission line. That can be an indicator that that particular B star is passing through a disk loss episode during the time of that observation. Now the question comes, well, is it possible to take the spectra of these kind of stars every month? How is it possible? You cannot take. Any professional telescope is very busy. So any allotted time which we are getting, we can take the spectra of a particular B star. But if suppose a particular B star is showing such disk loss or disk reappearance phenomena, and if we want to regularly monitor that star, then we need to take the help of non-professional people, amateur astronomers. Apart from we people who are taking the spectra of these stars professionally, there are ample amount of non-professional astronomers who are always observing BE stars all over the world. And they are doing a wonderful work. What they are doing, just to give a very brief idea, well, let me show you in our area what we are doing or how we are taking the help of non-professional people. So if you come to Google, if you just type this thing, BESS database, and if you click, what will come? This will come. Just click the first link. You will come to a page, BESS database. This BESS database is the largest spectral database for BE stars. Any amateur astronomer who has a telescope and a spectroscope can take the spectra of a B star and upload that spectra in this database. And that way, it helps us. So I feel today, one of my project students might have joined. His name is Smruti. He is a student. He is a MSc student from Pondicherry University. Just few days ago, he has completed his master's project with me. And his work was focused on understanding this transient nature of the B star disk variability, taking the help of proper data and also taking the help of this amateur database of amateur people. And by his particular research project, he has been able to find out, or he has been able to identify 19 new BE stars, which we can consider as transient BE stars, means the BE stars which have shown disk loss at least once in their lifetime. For that purpose, we have taken the help of this amateur database. How? Okay, let me show one example from his result. Okay, let me go to the result section. Okay. See, after his intense study, he has told that this particular star, HD 170682, this particular star might have shown a disk loss and formation episode within around 2 years during 1998 and 2000. How we can know that? How do we know that? How he became very much sure about that? Let me see. Well, how we can understand in astronomy research, how we know about the history of a star, how we know that this particular star, who has studied this star, how many papers exist basically on the basis of this star, what are the previous authors have done, what kind of work on this star. For that purpose, we have to take the help of some particular astronomical database. And that astronomical database is known as Simbad Astronomical Database. Just come to Google, type Simbad Astronomical Database. The first link you click, you will open this page. And this page provides you, this database provides you the data or the bibliography or the details about any astronomical object which is away from the solar system. So if I want to know about this particular star, which I have just pointed out, just go to this by identifier, because I want to search this star by the help of its name. Put this name and submit. Let's see what it comes. Yes, you see, this is the star HD. It is recognized as a B star. This is the coordinates of the star. You see, it is its V magnitude is around 8. It is not a very bright star. Its a spectral type is B52, and this is how the star looks like. This is how the star looks like. This is the image, real image of the star. And you go down, you see this same star has so many other names, 41 names it has. You can search this database with any of this name. And now you go down, you see till now from 1850 to 2024, 55 research papers exist where this star has been studied. You can actually go to all these research papers. Just click this display button. Just click this display button and you will get to know all the research papers where this star has been studied. Right from the first paper to the most recent paper. And yes, there are ways by which you can actually download any one of these papers. Suppose if I want to download, if you want to download it, just go to this button and download preprint PDF. So you can download the paper and you can read what work has been done based on this particular star in this particular paper. So like this, see, astrophysics, presently we are dealing with very sophisticated technology, and astrophysics is medical science and astrophysics. Maybe these two are the branches which uses the most sophisticated technologies for research purpose. And till now, if we want to know this particular star, apart from these research papers, they are all professional astronomers. Apart from them, somebody else has studied this star. Yes, somebody else has definitely studied this star. So as this is a B star, we can come to this BESS database, go to this section. You see, in this particular database, there are presently more than 290,000 B star spectra available, free. Just put the name of that star. Well, I need to put the name of the star. Okay. Just put the name of the star and search in that particular database. And submit. Now you see, there are presently 8 spectra which has been taken by these people are all amateur astronomers. If you want to see how the spectra looks like, this person has taken the spectra on 2009, 5th August. What was the spectra, how that spectra looked like? Just click here, plot. You see the spectra. So now, like this, we can ultimately track if we professional people cannot take the spectra of a particular BE star during a particular period of time. Suppose we do not have the spectra of this star during 2009 to 2016, but we already have a database where amateur astronomers from some place of the world are taking the spectra of that BE star and uploading it here. Then we can actually go and search their spectra and see, okay, during 2009, this star was showing absorption lines. Like this, we can take the help of this amateur database, mainly maintained by amateurs. There are also nowadays professional people who are also associated with that database. And we can ultimately bring out the history of a star or the history of the disk formation and loss, disk physics of BE stars. And till date, the amateur project in astronomy, which has given the most number of publications, is this BESS database. You can go to this BESS database publication section, and till 2023, you will see there are more than 120 publications have come out. And mind it, these publications are all authentic, peer-reviewed, proper research publications. So anybody who does work in this area, BE star studies, definitely has to take the help of this database. Well, we have also taken the help. You see, this is our works. These are all our works. So this is, I know that this particular project which I am showing is a bit difficult for many to understand, but this is just to give a glimpse that this is how in various aspects of astronomy in our particular area also, we take the help of amateur people. We take the help of amateur astronomers who are really doing good works. And yes, I would like to now stop here. This is what I wanted to tell. Thank you, everyone. We can open for questions. Yes. I hope I was audible, right?
Yes, sir, you are audible.
Yeah. So the whole PPT was visible, right? Because here we are facing some problem for the past 2 days.
Yes, sir. Yes, sir.
Okay. Thank you, everyone. So this is just a basic idea that yes, almost in every field nowadays, in the field of astronomy, in every area, we have to take the help of amateur astronomy. We have to take the help of non-professional people and citizen science people. All citizen science projects might not be listed in the same platform, and that is why this group is there, as a citizen science group. That is why this summer camp has been organized. But likewise, many of the citizen science projects are for every people. Anybody can join. Anybody can actually take part in this citizen science projects. But the particular project which I was discussing for my own area, yes, I understand that is a very specific project where people who are having their own telescopes, understanding about spectroscopy, how to take the spectra, how to normalize the spectra, they can only take part. This is just to give a brief idea that nowadays astronomy is a subject which is taking the help of non-professional amateur astronomers in almost every aspect. So thank you, everyone. I guess Ashwin Sinha, you want to ask something? Yeah. Ashwin, can you hear me?
Yes, Gaurav sir. Thank you for an excellent talk.
Thank you.
I just wanted to know what kind of spectrometers can amateur astronomers use to study B stars?
You can nowadays we need, so what kind means you can buy spectrometers from any particular good companies like LHIRS or CCT photometric spectrometers, but the resolution should be good. So we expect some spectrometers where you get some resolution of around 7 to 10 angstrom, means any two lines which are separated by 7 angstrom will be shown as two different lines. So those two lines should be separately shown. So any spectrometer which is having a resolving power of around more than 2000, which are low resolution spectroscopes, or more than even 1500, that is okay. So any telescope with which you can fit the spectroscope properly, then you can start observing the sky. Means I am not talking about any BE star category. Yes, definitely BE star or any other variable star. If you want to take the spectra of a star, you have to understand the spectroscopic resolution what your instrument is giving, and whether that particular instrument you can fit with your telescope properly or not. So that is important. If you can do that, then any particular spectroscope can help you. See, even the brightest stars like Sirius, if you want to take the spectra of Sirius, so you don't need very high powerful spectroscopes. You can take the spectra. But whether that spectra will be usable or not, that will be depending on where you are observing it, how you are observing it, your location, your instrument capacity, whether your instrument is calibrated with your spectroscope properly. These things you have to understand. So then it can be done. But for BE star studies, generally we have seen the people who are using spectroscopes, amateur people, they are also using a somewhat professional grade spectroscopes. Because we will see maximum stars in our category which we study, they are 8th magnitude, 9th magnitude, 7th magnitude maximum. So which you cannot see with the help of your naked eyes. Yeah. So that's why little bit good resolution spectroscopes are important. Yeah.
Okay, thank you.
Thank you.
If anybody is having any other queries, please feel free to ask.
Sir, I am Devendra Kumar. I would like to ask a question.
Yes, sir. Yes.
How can take the spectroscope? How can the spectroscopy of star through telescope?
You have to fit the. Yeah. You can.
I
So you
mean,
have
I
to.
mean, how can take the spectrum of a star through telescope?
Yeah. So the telescope has to be fit with a particular spectroscope with particular settings and everything properly done with particular instrumentation. Then instead of taking the image of the star, what will happen? The radiation of the radiation which is coming from the star will fall in the inside the spectroscope having grating. Means the radiation or the light which is falling in the spectroscope grating will be dispersed into its component colors. And that particular grating will help you in dispersing the light. After that, through proper channeling and collimation and adjustments, you will get the spectra. You will get instead of the image of a star, you will get the information of that star in the form of a spectra. So it's a long process. It's a long process. If any one of you want to visit anybody or go to any observatory, it will be very good. You can actually see how a spectra is taken properly. So this is with the help of the telescope, which is capturing the radiation, and the spectroscope instrument, which is converting that radiation into its component colors, or basically into spectra. So this is done.
Actually, sir, I have a homemade spectroscope at my home. I recently made it, and I took some spectrum of water body like
Water body.
the and so on through microscope. So it can be used for spectrum of a star through telescope, or it is
No, that
any
particular
any
spectroscope
kind
which
of
you have got.
special any kind
Yeah,
of
indeed.
special.
Yes. Astronomical spectroscopes have so many things which are very special. So you have to read first, and you have to understand. See, you are taking the radiation from a star which is very faint, which is coming from a very far away star. So when the radiation of a star comes and hits your telescope, how will you be sure that whether the radiation which is coming to your telescope is from that particular star, or from any foreground or background object, or from sunlight, or from some light which is nearby to your house? How will you be sure? So astronomical spectroscopy is definitely a separate area of study. You have to understand that it's not about that you know what is a spectrum, that is good. But astronomical spectra and spectroscopic instrumentation in astronomy is a completely separate field of study. That you have to very well understand, then only you can take the spectra. And a simple spectroscope which you have made, you can take the spectra of simple objects. But for study purpose, for analyzing purpose, you have to take the help of professional spectroscopes. Because you have to after taking the spectra, you have to do lots of other works, so that spectra which is coming from the star will become usable spectra, readable spectra, the spectra which I have shown to you, wavelength versus intensity. So that kind of usable spectra, for making that usable spectra, there is a lot of process which goes on, lots of process. And you have to know very well the astronomical instrument which you are using, your size, what type of objects you are taking, their physics, very well you have to understand. Then only you can take the spectra. Otherwise, you will get the spectra, but how will you be sure that the spectra you have taken is coming from that particular object? Right?
Thank you so much, sir. Okay, I will try to take some spectrum of stars through my DIY spectroscope, and
Definitely
I
you
will
can.
send it
Yeah.
to you.
Definitely you can.
Thank
Sure.
you. Thank you. Thank you.
I guess Girishji was also raising his hand. Maybe so the next speaker will start talk. So maybe the last question which we take can be from Rishji. Yes. Okay, if not, then I guess Aristo, we can shift to the next
Yeah.
speaker.
Okay, sir. First of all, thank you, Gourav sir, for this wonderful presentation. And our second speaker for today's session is Dr. Himadri Shekhar Das. He's a professor and HOD of physics at Assam University, Silchar. So I'd request Himadri sir to start with today's session.
Yeah, thank you very much. Am I audible?
Yes, sir. Yes, sir. You're loud and clear.
Is it visible? The screen?
Yes, sir. The PPT is visible.
Yes. Thank you very much for inviting me this wonderful session. I was just listening to the previous speakers and Dr. Gourav's talk. It was very nice.
Sir, your mic is muted.
Yeah, am I audible now?
Yes, sir. Yes, sir. But now the PPT is not visible.
Yeah, I'm just sharing the PPT. Good evening to all of you. I was just listening to Dr. Gourav Banerjee's talk. It was very nice. And I can see many citizen scientists had joined to this session. Particularly the object, celestial object, which I'll be going to present before you. It is one of the most interesting objects in our solar system. And sometimes we call them as visitors. And how one can engage himself or herself in hunting that particular celestial objects. In this talk, I'll try to explain you. Let me first show you the PPT. Is it visible, the PPT?
Yes, sir. It is visible.
Okay. I'll also share some animation also in this presentation. And I don't know whether it will be visible or not to the audience. My topic is comets, unveiling the mysteries and techniques of comet hunting. So basically, comets are small celestial objects in our solar system, and which has many significance in astronomical world. And let me tell you that my PhD in 2005 was actually concentrated on the study of comets. And later, we had also studied comets from different observatories in India, particularly from Pune, Ayuka Girawali Observatory. Then we had also studied comets from Eris, Nainital. We have a couple of observations from India related to comets. And as I told you, it is one of the mysterious objects in solar system. So let us know why it is mysterious, as well as why the study of comets are important and how the citizen scientists can actually engage with some projects in comet hunting. I'll step by step, I'll tell you. So let's start with comets. Can you see the video which is playing?
Yes, sir.
Yes, yes, it is visible.
And what about the audio? Is it visible?
No, no.
Audio? Can you hear the audio?
No.
Okay.
No,
The
sir.
audio, you can actually share the audio if you just share this just a single window. Then I think the audio we can hear the audio.
Single window, no?
Yes, sir. Like that particular screen only.
Okay, let me see. because that audio is very interesting, and that's why I wanted to show the. So if just a minute, I'm very sorry.
No problem.
Anyway, no issue. Actually, in this video, you can see a celestial object is rotating. That object is basically comet. It is made up of ice and rocks, and it comes far away from the sun. And when it enters into the orbit of the solar system, the comets are visible. So here, if I want to introduce comets in front of you, it is comets are basically dusty snowballs which orbit the sun. They're made of ices such as water, carbon dioxide, ammonia, and methane mixed with dust. And these materials came from the time when the solar system was formed. So you can see here a nice photograph of a comet, Neowise. Comet Neowise is the name of a comet which is very popular when it appeared in the year 2022. And that time, several people around the globe has observed this particular comet. And so today I'll talk much about the comets, why comets are so interesting objects, and how one can uh, detect the comets. This is some cartoons I'll show you because this is what the citizen scientists, young citizen scientists are there in this group. And you can see that is, I had given the name Cometoon. Cometoon means comet cartoons, and I have combined the two words, and it becomes Cometoon. So here you can see Henry was sure, he had visually confirmed that comets are really just dirty snowballs. And I think many of you went to the might have played with this snowball, and you can see the definition of comets. Comet's definition is comets are really just dirty snowballs. Here, first of all, I would like to refer the historical background. You can see in this picture in 1007, a comet appeared, and you can see a comet. It gave off fire and flames in every direction. And the Book of Miracles, which was printed in 16th century, first we could see such type of paintings. Because as you know, that time there was no photograph, and but people could draw the pictures nicely. And here you can see that picture. Next picture, this is a very famous picture. It is Bath Tapestry in England. And here you can see the comet picture. In the top of the picture, you can see the comet is seen, and it is 1066. Here in 1300 AD, you can see another picture which was appeared in the sky. And in that year, on St. Andrew's Day, an earthquake shook the ground so that many buildings collapsed. Actually, I'll tell you that the appearance of a comet is actually associated with some superstitious belief. People that time believed that sudden appearance of a comet in the night sky may bring disasters, calamities, tragedies, earthquake, flood, etc. But later we had seen that that is just a celestial phenomena. You need not to bother if a comet is appearing in the sky, and you have to welcome the comet. You can see in 1400 AD, a big comet with a tail appearing in the sky in Germany. And that was actually, that time, it was followed by great terrible plague in Swabia. So again, the appearance of comet is by chance, plague was there that time, but people had related the appearance of comet with the terrible plague. Next year, this is a very nice comet. You can see it's a very big tail, and it had taken the attention. And you can see that people are coming out and was observing this beautiful object in the night sky. This is six-tailed comet of 1744. It is a very rare comet because we could not see any photograph of such comets in later part. But here you can see that it is the six-tailed comet of 1744, and we have got this picture from the archive. This is a great comet of 1843, and this comet has developed extremely long tail. Till date, it is the longest tail observed. And again, I'm telling you that time photography was not so developed, and that's why only the paintings are available. This is the great comet of 1853, the anthropomorphic comet with a tail composed of earthbound objects, and you can see how nicely the painter had drawn this particular image. Then you can see comet Halley. So these are the real photograph taken by the telescope as well as CCD camera. And this is comet Halley. Comet Halley was one of the interesting objects which appeared in the year 1986. At that time, different scientists around the world gathered and studied that particular comet. This comet Halley is a very historical comet. I will tell you why it is so historical comet. Then it is another interesting comet which appeared in the year 1996-97. The name of that comet is comet Hyakutake. It was actually discovered by Japanese. This was actually discovered by Japanese amateur astronomer Hyakutake. That's why the name given comet. You should remember that whenever a person discover a new comet, then the full credit goes to that particular observer. And it has been found that the comets were majority of the comets were discovered by amateur astronomers like citizen scientists, and that's why this name given. Comet Hale-Bopp. Comet Hale-Bopp is another interesting and very bright comet, which was also appeared during the year 1996-97, and this comet is also got the attention around the globe. Because this was a very bright comet, and this comet was independently discovered by two amateur astronomers, Ian Hale and Thomas Bopp. And in my last lecture, probably, I talked about Thomas Bopp, who was a citizen scientist, and I told you that how Thomas Bopp, though he is not a professional astronomer, but he discovered the bright comet. And it's a very nice comet taken by some unknown photographer, Comet McNaught. And this is Comet Levy. Comet Hale-Bopp, you can see. And the beauty of that comet is you can see two tails of the comet. One is blue color, and another is white color comet. And that comet also took attention around the globe, as I told earlier, because of its tail, because of its size, because of its brightness. This comet, Comet Gerard, it was actually discovered in the year 2009, and this comet was this photograph was taken by our group. Particularly, I was observing this comet in the year 2012 from Ayuka Girawali Observatory, Pune. And that time, that comet got attention around the globe, and we had a published paper related to this comet. And that same comet was also captured in 2012 from Eris Manital Observatory. This is another interesting comet which I wanted to show you. It is comet Izon, and this was very active during the year 2013. And why I am showing this particular comet? Because this comet ultimately crashed into our star Sun. So this was actually basically a sun-grazing comet. Sun-grazing comet means the comets which could not come out from the tremendous gravitational attraction of Sun, and ultimately it crashed into that particular star, means our own star Sun. Here I will show you one of the most famous comet. Last 2022, this comet was very bright around the world, and some photograph you can take. You can see one photograph of comet Neowise from the uh, International Space Station. This photograph was taken, and here you can see it was marked with the red marking is there. This is the comet, and you can see our art is there. And this photograph was taken from the International Space Station. So this is how the comet looked. If you so some photographers around the amateur astronomers as well as the professional photographers or professional astronomers had taken the photographs. This is another photograph you can see of that comet. And also, when professional astronomer is going to shoot the photograph, they have different ideas. And you could see in this picture, girl is standing and light is coming out from her finger. It was a very nice idea, and you can see how they are actually. And it was particularly this photograph was shared in the Instagram profile. This is another photograph. You can see in the early morning sky, seen from near the Grand View of the Colorado National Monument west of Grand Junction. So this is another photograph. So this is a very nice photograph. You can see in the Seven Magic Mountains, Las Vegas. And so people from different corners of the globe try to photograph that comet. And you can see the nice photographs are coming out the screen. So this is near a mountain when the photograph was taken. It is taken near the Belarus. Okay. Now, you might have seen the comets both in painting as well as the real photograph taken by amateur astronomer. But when we start looking at the history of the comet, then the question arises, who first actually recorded the listing of comet? And we have found that the literature review, Chinese observation of comet Halley in 240 BC was the first listing of comet in the recorded history. And that set of comet illustration you can see here, this picture, is written in a silk book during the Western hand period. That time you know that these are the vegetable ink on a cloth. They have drawn this picture, and you can also see the Chinese dialect is there. I don't know actually the Chinese, but those who know, they could read it out. And basically, this is showing you that Chinese observation of comet Halley 240 BC was the first listing of comet. You can remember that you might have seen that photographs earlier. I told you that there was a church in England where this is shown by an embroidered cloth. And here you could see in this picture, this red mark, it is basically comet Halley. And that time, comet Halley took a attention around the in that particular area, and it was actually depicted in the painting. comet painting was actually I collected some sources and wanted to see how comets are associated in different field other than astronomy. You could see a comet painting. In the left side figure, you could see two-headed dogs. Then baby are crying, and you could see two comets in the two different corners of the picture. And the interesting fact is that the rain is there, blood rain. What does it signify? It signifies that the appearance of comet is actually associated with some tragedies, and that's why you could see a two-headed dogs. Then babies are crying. This uh, blood rains are there. So this picture is actually depicting you the superstitious beliefs of ancient people. And then here in this right picture, you could see a horse with his tail, and this tail is actually telling you about the comet's tail. Here another painting, nice painting near a palace, and you could see a comet, and that comet is comet Hale-Bopp. And when comet Hale-Bopp appeared in the year 96, 97, as I told earlier, that time one painter had drawn this picture, and that I took from some sources. And this is one of the famous cartoon which appeared in one of the newspaper in 1910. And in that cartoon, you could see that one comet is coming and it is colliding with Earth, and it has destroyed the Earth. So that time people had fear in mind that comet may come and collide with Earth and can bring disasters. And also the cartoonist who was actually drawing this cartoon, he was also very, what to say, he had fear about the comet, and he drawn this picture, and you could see that people that time was very anxious to know what would be going to happen. And here you could see in this picture, the good thing is that the sun is laughing. So here that demon is nothing but comet Halley, and here sun is depicting that the astronomers, because astronomer knows that this comet Halley will not collide with Earth, and it could pass very close to the Earth. And that time also the comet Halley uh, passed very close to the Earth. As I told you, I'll show you some comet. Here you can see that Greece people were the first who systematically studied comets. In this particular cartoon, you can see that dinosaurs are looking at the sky, and the disappearance of dinosaurs is associated with the collision of comets or asteroids in past. People believe that. We have many theories which is telling us that because of the collision of comets or asteroid in past, these dinosaurs actually disappeared. So here, there you can see, oh look, a shooting star, make a wish. Again, if they are seeing some fly, then again the same, oh. So this picture is actually depicting you that the dinosaurs who are not actually have fear about comets. Here, one more cartoon. You can see Bob is telling, no, I've not played you if you are the last dinosaurs or not. And in the background, you could see one comet or asteroid object is coming. So this particular cartoon is telling you that though the comet is very small, but we have to observe the comet with a big telescope, and all are welcoming the comet, because though ancient people have believed that comets may bring disasters, but you know that this is a regular phenomenon, so it has nothing to do with disaster, calamities, etc. In this particular cartoon, you can see the famous cartoon character Tom is actually sitting the NASA asteroid alert system, and you could see that already an asteroid is approaching towards Earth, and he's very fascinated about that information. So here, one more one lady is asking, Dr. Hubble, is this asteroid going to collide with the Earth? And he had told no comment. Normally we say no comments, but here he is telling no comment. No comment means it is basically asteroid. Here in this cartoon, you can see there is a conversation between mom and kid, and mom is asking who had broken this glass, and the kid is very intelligent because he knows astronomy, and he was telling, was not me, mom, must have been one of those mini comets. So his theory is that mini comets might have uh, collided with the glass screen, and because of that, that glass was broken. During 1999, that time the internet around the world became very famous, and people are trying to store the information on the website. And that the London Times newspaper had come up with this particular photograph. So see our website at www.helis.com. Okay, so this is how actually .com was becoming popular during that time. Here, not only in normal cartoons, some comics were also published, and that time you could see that a boy and a master and his dog were watching the light in sky with meteor shower and all these comets, and then there is this call uh, from the home. There's a really good TV show on in here about astronomy. Oh, cool. And then they had to go return back to the TV. But the dog was upset because he's telling, wait, this is one of those subtle jokes, is not it? I hate these subtle jokes. What is the joke here? What is means the dog wanted to see the light sky, but as master was going back to his room, that's why he's upset. So you could also see comet in literature. Here you could see a boy, a kid, was looking at comet Halley, and you know that comet Halley, the periodicity of comet Halley is 76 years. And here, after 76 years, the old man, he became old, and you could see, but after 76 years, person is not there. And this particular poem was written by one of my mentor in Bengali. I think if some of you citizen scientists who are attending this session, if you know Bengali, then you could read it. Actually, basically, Professor Bhattacharjee, he had written that Halley's Doomketu will be, means Halley's comet will be coming after 76 years. But that time he would not be alive to see his that mystery, that interesting comet. So like that, he had written this picture. So I wanted to tell you that comet had also drawn attention to the poet and writer. Here you can see another limerick written by the great American novelist Mark Twain. And he written, Halley's comet is seen in the skies on the day that he opens his eye. It is seen once again in the life of Mark Twain on the day that the great writer dies. So, since the comet is made out of ice, what he had written, mixed with dust, so it is not too nice, but it circles the sun. Halley's comet, the one that for Twain in his life appears twice. And the interesting point is that Mark Twain's Halley's comet was in the sky at that time. When he was writing that particular limerick, he was actually, you could see that comet. And as I told you that that comet was actually visible later in 1910, but Twain died on April 21st of that particular year. So these are comet jokes. So what I have to tell you that comet is everywhere. from literature to painting to arts. It is not only limited to astronomy. And you could see this particular comment jokes. I'm not repeating it, but if it is there in the screen, you can read it out. Very interesting is that when I was surfing the internet, at that time also found that comet is also there in fashion industry also. There is only cosmic effects collection where this particular name was given, comet. Could see the beautiful color nail uh, used by the nail polish, and also for the people who loves to drive, they have a gigantic fourth Helix comet. So the name model is gigantic fourth Helix comet. I don't know whether this model is now available or not. So throughout this initial part of my discussion, I had told you that comet is actually not associated with the astronomy people, but it is also got attention from different uh, fields, starting from fashion industry, then the common people, then literature, everywhere it got the attention. Now, if we are going back to the science. What is a comet? Comets are small celestial bodies several kilometers in diameter. It consists mainly of water, ice, rock. Okay. And as I told you that it is associated with superstitious beliefs like disasters, calamities, tragedies, etc. That time people had believed that comet may bring disaster. But nowadays, after when we had got information regarding the comet, we found that comets do not bring these disasters, calamities, tragedies. Now people welcome the comets because if you study comets, you can have information about the origin of solar system. As I told you that in ancient records also, we had got the record of comets. And first scientific record was done by Tycho Brahe in 1577 AD. And he first observed the comet with accurate instrument from various places in Europe. Now, particularly, we'll mm, concentrate towards the revolutionary works of Edmund Halley. Edmund Halley, for the first time, using Newtonian mechanics, showed that comets which had appeared in 1531, 1607, and 1682 are the one and the same comet in the period of 76 years. You know that when we consider two bodies in our solar system, and if they are gravitationally bound to each other, then we could consider an orbit as per Newton's law. And also, you might have idea about the Kepler's law of planetary motions. So Edmund Halley was working on that, and he found that if whether comet is coming from the outer world or not, that was that time a big question, because we don't know suddenly a comet is appearing in the night sky, and it disappeared after a few months or a couple of months, and then again a new comet is coming. So that time that question was arising in our mind, that whether comet is a part of solar system or not. Then what Edmund Halley did, he had taken the uh, historical evidence of some famous comets in past, and he found that in a particular year, one comet is repeatedly coming, and he found that the period of that comet is 76 years. And then he used the Newtonian mechanics and found that yes, it is possible as per Newtonian mechanics. And what he predicted that the same comet would return in 1758. So in which year he predicted? He predicted in the year 1753, 5 years before. Okay. And interestingly, the comet did appear in 1753. 1958. But unfortunately, Halley was not alive to see his glorious prediction. He probably died in the year 1755. So though he made the prediction, but remember that prediction is not like a simple prediction. That prediction was based on the scientific theories, means Newton's prediction theory. But unfortunately, Halley was not alive to see his glorious prediction. And this famous comet is now called Halley's comet because he for the first time uh, talked about that comet. And Halley's comet, 1986 comet Halley lasted here. So it means that after 76 years, this comet Halley will again appear in the sky. So what information we got from this study? We got this information that uh, the comet is periodic in nature. Okay, means comet has a specific orbit and it takes some 76 years to, for this comet, takes 76 years to rotate around the sun. So here in this particular slide, you can see, if I ask you what is the structure of comet, then the answer is the three major comet have a three major parts. The first one is the nucleus, which is having 1 to 10 kilometer size. Then the coma. Coma is surrounding the comet. Coma is there, gas and dust. And the size is around 10 to the 4 to 10 to the 5 kilometer. And this coma appears whenever the comet approaches towards sun. Otherwise, the size of the comet is very small, around 1 to 10 kilometers. But whenever it approaches towards sun, because of the radiation from sun, this comet, the coma appears, and then the size of the comet, means the volume of the comet increases. Okay, then the size becomes 10 to 4.5 kilometer. And when it approaches towards the distance, then the tail of the comet is approaching. You can see the comet is uh, identified by its tail. So this is the beauty of a comet. And you can see in the right side of the picture, animation is there. And in that animation, you could see that the comet is rotating, okay, in an elliptical orbit. And whenever it is approaching a particular distance, then the tail is coming. And the interesting part is that the tail of a comet is always away from the sun because of the solar radiation pressure. And there are two tails, one is ion tail and another is dust tail. You could see in this picture, this blue color tail is there, straight tail is ion tail, and the white color is the dust tail. So this is the great comet of 1843, as I told you. And that time it was painted by one of the artists, it is James Howard. Howard, you can see that this is the longest tail of a comet observed till date. It is 3.3 billion kilometer. And for your reference, I'm telling you the distance sun and earth is 1 billion kilometer. It is almost 2x the distance between sun. But remember, no comet is very, the tail is very long, but the size is very small. So it doesn't matter. So sometimes we call comet as bags full of nothing. So basically, comets are classified into two groups. One is periodic comets, and there is non-periodic comets. And there is a term we use generally, eccentricity, in mathematics. Okay, for an orbit, if it is eccentricity is less than 1, it is periodic comets, and if it is more than 1 or equal to 1, it is non-periodic comets. And you can see here that period comets are both short period as well as long period comets. Short period comet is less than 200 years time period, and long period comet are more than 200 years. And these short period comets are also classified into two groups, Halley type comets and Jupiter family comets. Jupiter family comets are governed by the Jupiter's gravitational field, and usually the orbital period of that comet is less than 20 years. The non-periodic comets are Austin, Bradfield, Levy. These are all non-periodic comets. It means that this comet had been seen for a single time, because this comet, there is no chance to come back those comet in future. Okay. I'll show you 4 animations, which I don't know whether the animation could be seen to you or not. If it could not be seen, just tell me. Is it visible?
Sir, it is visible.
Yes, yes.
Yes, it is visible.
Yeah, very good. So this is an animation because in later part I will tell you about the project where this particular animation will be used. So this was taken by one of the telescope. Telescope means it is space telescope. We call it SOHO. And here you could see uh, the sun. This is coronagraph, and you could see that the disk of the sun is blocked by one of the instrument. And here white circle, you could see white circle is the actually size of the sun. And you could also see that solar flare is coming out from the sun continuously, and one comet is moving. And another interesting fact is that the tail of comet is away from the sun. I'll show you one more animation. So here you could see, have you seen something in this video? Anyone? Could you see something interesting in this video? I'd like to hear from citizen scientists. Anyone? Now you can comment. You can just switch on your audio because I could not see what comments you are typing. Can you see two objects are moving? Yes. So you might have seen in the left side of the figure, two objects are moving. This is repeatedly this is coming because I have switched on the uh, play again mode, and you could see two comets coming very close to sun, and it has ultimately could not come out from the sun, and these are known as sun grazing comets. Sun grazing comets because they are very close to the gravitational attraction of sun, and it could not come out from the sun. And we call those comets as suicide comet. Then they are making suicide. Okay. Now I'll show you another video where you could see one comet is approaching, and you could see how the tail is forming. Yes. So again, this comet could not come out from the gravitational attraction of sun. Here you could see that the comet is coming, but ultimately it is a sun-grazing comet, and it could not come out from the sun, and ultimately it destroyed by the tremendous gravitational attraction of sun. The last one is very interesting. This is comet Hyakutake, and you could see how the tail of a comet is changing its direction, and it was photographed nicely by a SOHO spacecraft. Okay, so in comet hunting, citizen scientists has to find out this type of image, and they could check this particular image, and from that image they could find out whether a comet is there or not in the screen. As I told you, comet is made of water and ice. So if I ask you how much water is in the comet, so here I can show you one example. There is about 13 million Olympic swimming pools of water in comet neowise. So it was actually one of the news conference in July 15. Uh, they have told that comet contains around 13 million Olympic swimming pools of water. So you can understand that if you could bring a comet to our Earth, so you could get a lot of water. Now, from where comets are coming? So, Opik in 1932 first suggested a cloud of comets surrounds the solar system. So here you can see the sky color. These are all comets. And Jan Henry Poet in 1950 calculated that comets are situated somewhere between 40,000 astronomical unit and 100,000 astronomical from this sun. This great reservoir is now called Oort cloud. Okay, and for your information, let me tell you that astronomical unit is the distance between sun and Earth. It is around 1.5 billion kilometers, 15 crore kilometers. Okay, so what is important here? Here important is that our sun is surrounded by a cloud of comets, and there contains billions of comets. So sometimes due to the attraction of nearby star, uh, comets enter into the new comets enter into a solar system, and sometimes it trapped due to the gravitational attraction of Uranus, Neptune, Jupiter, and Sun. And then it will become a periodic comet. And some comets are not influenced by those planets, and they enter the solar system and they just come out from the solar system, and they are known as non-periodic comets. The question arises is what will happen if a comet encounter a planet? This is very, very important because at the beginning, I was telling that dinosaurs disappeared due to the encounter of comet with our planet Earth. So, our question arises in our mind that if what will happen if a comet encounters a planet? The, we are very lucky that we have observed this type of incident in past in 16 to 22 July 1994 in planet Jupiter. The name of the comet was Comet Shoemaker-Levy, and it has broken into more than 20 fragments and ultimately it crashed into Jupiter. And after collision, the energy release was around 10 million megatons of TNT approximately. You know that after collision, lots of energy is generated, and the energy release was that much. So if you want to get the idea of TNT, let me tell you that atom bomb which actually destroyed the city Hiroshima was equivalent to 20,000 tons of TNT. Just you divide that number, you could see that that comet is sufficient to destroy major cities in our Earth. So that's why you could understand that if a comet is colliding with Earth, then it's highly dangerous for the people who are staying on Earth. So comet is always an alarming for all of us, but let me tell you that there is no chance of any comet to encounter our Earth in next 100 years. If a new comet is approaching, that is a separate issue. But as per our calculation today, there is minimum chance of colliding with Earth and the colliding with comet with our Earth. And recently, you might have heard about DART mission, which was done by NASA. And now we had a technology that we could divert the orbit of asteroid. And now we'll try to see whether that technology could be used to divert the orbit of comet. So that whenever a comet is coming towards us, we will send a missile or we will send a rocket so that it will divert the orbit of comet, and then we will be safe on our planet Earth. So here you could see that picture which was taken by Hubble Space Telescope in the year 1993-94. And you could see that the single comet has been broken to 20 pieces because of the tremendous gravitational attraction of Jupiter. And here you could see initially in July 93, it was the same single comet, and then as time passes on, the uh, comet has been broken into several pieces. Several space missions to comets were organized. I'm not telling you in detail. Different countries around the world had organized many such missions to study the comet. So here is the list to see. Space mission to comet Halley was organized in 1986 when it appeared in the night sky. And then 5 spacecraft were sent to study comet Halley, Geo2. It is Vega 1, Vega 2, Geo2 space mission, and 2 Japanese spacecraft, Sekigake and Suisei. The question arises, the basic question, why study comets? Why comets are important to study? The first question is, according to current theories, comets were debris left over from the building blocks of outermost planets. So if we study comets, it will give us origin of solar system, because it has been found that the isotopic ratio of carbon-12 and carbon-13 in many comets equal to 90, which is same as solar system. So what does it mean? So if we study comets, it will give us least processed and pristine materials of early solar nebula, from which the present day solar system has been formed from some 14 billion years ago. 4.5 billion years ago. Another interesting feature is that if we study comets, it will give us origin of life on Earth. There is a theory. All life on Earth is composed of organic materials, and the elements hydrogen, carbon, nitrogen, oxygen, sulfur, and phosphorus are believed to be essential for all living systems. So before going to that part, let us tell you about one experiment. It is very popular in biology. It is Miller's experiment. What he did, Miller in 1953.
P stands for
Pardon? P stands for phosphorus.
okay.
These are all organic elements: hydrogen, carbon, nitrogen, oxygen, sulfur, and phosphorus. These are the first name. Okay. So in 1953, Miller did an experiment. I think in later part of your study, you will know about this experiment. The experiment is like that. He took a mixture of ammonia, methane, and water, and then passed an electric discharge. And because of that, it produced several kinds of organic molecules, including amino acids. So what does it mean? All life on Earth is made up of amino acids. And Miller found that if you take a mixture of all these chemicals, life can be formed. And that time there was a popular saying that Miller had created artificial life in the laboratory. But remember, that is an experiment. That is an experiment. And then later, scientists had come up with the idea that that same phenomena could have been taken place on the early stages of Earth, leading to formation of line of Earth. What does it mean? It means that in past, some comets might have encountered with the Earth, and that time these chemicals were there in the comet. So comet had brought life to Earth. So what does it mean? It means that all of us now staying on our planet, all of us are actually aliens. Aliens in the sense that if we believe in this particular theory or hypothesis, then the life had come from comet. Is not it very interesting? That's why still that question we are searching answer of this question, how life started on Earth, and this is one of the theory. This is not the only theory, but other theories are there regarding the formation of life on Earth. But one important point is that the origin of life on Earth is associated with the comets, and that's why astronomers are very enthusiastic to know more data. Will someone send me the data? In case of asteroid search campaign, I think many of you are attending asteroid search campaign, and in that campaign you have to come up with your own citizen science club registered with NASA or some other. You have to send your details to ISC, and then ISC register your group's name in their website, and whenever the campaign starts, they send images, and then that image you take, and after that you could submit the report. But in case of this particular campaign, you do not need to go to any such campaign. You can directly download the images from the Soho website, and it is a software based. There is software, single software is required, either Photoshop or GIMP, GIMP. GIMP is very popular software. It is a free software. Photoshop is a paid software, but GIMP is a GIMP. GIMP is a uh, free software. You can download it and you can start comet hunting. And you can also get comet hunting tutorial. Nothing. Three images. They will supply you three images, and if you click on that images and animate the image, you could see that object. If an object is moving, then you could spot it. Whenever you spot it, immediately you report to the project administration. The website is the email link is fundraiser.nrl.navy.mil. So these are basically the website where you could get the information. Okay, and maybe in some other lecture, because time is already over, 1 hour I had taken for this presentation. So maybe in some other day we could show you how one can use the GIMP software or any Photoshop software to detect the comet. I'll stop here because already 1 hour is I have completed 1 hour. So if you have some questions, quickly we can have those. Thank you very much for attending this session.
If anybody is having any queries, please ask it right now.
Do you have any query, any questions?
So someone in the YouTube chat is asking, is visibility of the comet is really associated with disasters? Sorry, did you get the question?
Yeah, it is there in the, I think.
So no, chat.
What is
No,
the
sir. Someone asked it in the YouTube chat, in the YouTube live stream chat.
Okay, okay. And let me see the. I actually wanted to ask this: invisible comet really associated with disasters? No. In my talk, I told you it has nothing to do with any disasters or calamities, because it's a regular phenomenon. And when a new comet is coming to our solar system, we should welcome that comet because it's a visitor, a spectacular visitor to our solar system. So it has nothing to do with any disasters or calamities. I can see one comment from DK Sir Arkhon. So I also took a photograph of green comet on last 5 September 23 with my 12 inch Dobson telescope and mobile camera, and later on 12 comet and before one comet. Okay, Devendra Kumarji from UP. Yeah, it's very nice. We'll be happy to see your picture. If you could share with us in Citizen Science Group, as a Citizen Science Group, so that we could see this photograph. Aries Planetarium Nainital published the image of Nishumara comet in the national page of the Indic Chakran. Okay, very good. Yeah, so as I told you that we had also taken a couple of comets from Aries Observatory in Nainital, and we had a couple of papers published in some international journals related to comets. So it is very nice to hear from you. Anyone want to ask some other questions related to this? Ashwinji, you want to ask?
Yes, sir. Some of us actually have 10-inch and DK sir has a 12-inch telescope.
Okay.
So we only hear about comets that are potentially visible to the naked eye. So Nishimura
Okay.
got a lot of attention, but Hale-Bopp took a backseat.
Mhm.
So is there any place where we can get notifications when the comet magnitude, say, comes to around 9 or 10, when such a comet is close enough to be observed?
I'll just share you a link in the this portal where you can get which comets will be visible in the northern hemisphere. Just now I had shared the link. Just click on it, and you could see which comets will be visible in the next few months. Okay.
Okay, sir. Thank you. Thank you very much.
So here also you can get the magnitude range and all these things. And if you click on the particular comet, you'll get the information about comets as well as photograph. If someone is taking the photograph of that comet, that is also there in the particular page. Could visit.
Thank you. Thank you.
Thank you. Okay, so if there is no question from anyone, then thank you very much for giving me an opportunity to interact with the citizen scientists in this forum. Thank you very much.
Thank you, Himadri sir, for this wonderful presentation, and thank you to everyone else for taking their time and joining the session.